Assalamu alaikum, dear students. Today's topic is impulse. From Newton's second law of motion, this we know that force is equal to a rate of change of momentum. That means force can be also calculated change in rate of change of momentum. वो क्या हुआ? Suppose here I take here a body. It is having mass m. The mass of the body cannot be changed. Suppose its velocity is u, initial velocity. And suppose after in time t, duration of time t, its velocity becomes v, final velocity. It is the initial velocity, this is the final velocity. We know that change in momentum, we know that momentum is equal to, if you remember in the previous, momentum is equal to product of mass and velocity. That means mass and velocity. Mass and velocity. If we here change in momentum, if we write initial momentum is equal to mu, final momentum if I write here, it is, you know, it is mv. If I write here change in momentum change in momentum it is final momentum minus initial momentum. That means final momentum minus initial momentum. That means mv minus mu. Okay, if I say rate of change of momentum, that means the change in momentum, the initial momentum was mu and final momentum was mv. The change in momentum, that means change in momentum takes place by the change in velocity. The velocity changes during the interval of time t. That means rate of change of momentum is equal to rate of change of momentum is equal to mv minus mu divided by t. This from Newton's second law of motion, by definition, force can be calculated. That means from force can be also calculated by the rate of change of momentum. It is very easy to calculate from Newton's second law of motion force. We can calculate mv minus mu divided by t. That means force can be easily calculated by using this concept of Newton's second law of motion. That means rate of change of momentum, final momentum minus initial momentum. This is the amount of time t is the time taken to change the momentum from initial momentum to final momentum. By using this, we can easily calculate the force. That means force can be calculated from Newton's second law of motion by applying Newton's second law of motion here. But here the case is, when suppose I take an example, another example. Suppose this is the cricket ball. This is the batsman here. Batsman, he is playing cricket. A bowler is doing a ball. Okay, we know that mass of the ball, it remains again unchanged here, mass of the ball. If a cricketer bowls the ball with some velocity, suppose use the velocity of the ball, and it is coming towards the cricketer, towards the batsman, but here the batsman hits the ball, and suppose its velocity becomes v. But here, that means the initial velocity of the ball, the bowler throws the ball towards the cricketer with the velocity v, and it hits the ball through a bat with the velocity v. That means u is the initial velocity of the ball, v is the final velocity of the ball, and we know that m is the mass of the ball. The mass of the ball does not change. But here the problem comes, this bat comes in contact with the ball during a very short interval of time. It is such a short interval of time, it is practically impossible to calculate this short interval of time. I hope you have got it. That means, and when a cricketer hits the ball during this short interval of time, and the change in velocity becomes very high, but that means change becomes very high. That means the force which the batsman is applying on the ball is also very high. I hope you have got it. That means Cricketer hits the ball during this short interval of time. This short interval of time, it is very impossible to practically to calculate such short interval of time. That means if I here calculate, see here force, but force is also very impossible to calculate because it is a large amount of force that and large amount of force has to be calculated during a very short interval of time, which is practically very impossible. That means there is again a change in momentum. That means mv minus mu divided by t. But here the time interval is very short. We write here is dt because during this time this the velocity changes take place very friction small amount interval of time. It is practically it is very impossible to calculate such short intervals of time. That means if such a case arises where if such a case arises where a large force acts for short interval of time and produces infinite change in momentum. That means why it produces infinite change in momentum? Because the initial velocity was but we know the initial velocity, and when batsman hits the ball, it hits it tremendously. It reaches outside the boundary very short interval of time. But the contact between the bat and the ball is very short interval of time. That means large force acts for a short interval of time on a ball, and it produces a large change in momentum. When such things apply, it is very impossible to calculate a force. But in that case we have to calculate the impulse. What is the impulse? When we transport here it is f multiplied by dt is equal to change in momentum mv minus mu. For that purpose we have to calculate the impulse. That is impulse is the it is the large force acts for a short interval of time and produce an infinite change in the momentum. That means when large, I hope you have got a large force acts for short interval of time and produce infinite change in the momentum term is called impulse. That means for that we are not able to calculate the force and time directly. We have calculate the impulse. Impulse is the product of these two things. We can calculate it by change in momentum. As we know that mass of the body, we know the initial velocity. That means the velocity which the bowler throws the ball towards the batsman, and we know the final velocity. When that means it is very easy to calculate in that case impulse. But it is very difficult to calculate the short interval of time or a large amount of force. But we can calculate collectively force into time. That is called, we can calculate impulse. That means impulse that means the force which acts on bodies for short time and is called impulse. The impulse can be also defined as a product of force and time short interval of time. Mathematically we can write impulse ऐसे भी लिख सकते हैं G is equal to force into delta t. Delta t equal to the large amount of force which acts on a short interval of time. Okay, this is sometimes this that means m plus is equal to change in momentum. I hope you have got it. This change in momentum. How can we calculate it? Suppose body is having initial velocity u and having a mass m, and suppose the body got final velocity v during a short interval of time. How during a short interval of time? Such short interval of time which is practically impossible to calculate the short interval of time. Suppose I have given an example when a batsman hits the ball, or when we hit anything, when we jump anything, when we catch anything, or kicking. These are short intervals of time and we produce a large amount of force. For that case, here we get that means from Newton's second law of motion, force is equal to mv minus mg. But here we write dt. Why we write dt? This dt is the small interval of time, because this moment change in momentum takes place during short interval and produce a large amount of force. That means large force which acts on the short interval of time and produces large change amount and infinite change. A large change in the momentum is called m plus. Mathematically, we can write F plus is equal to mv minus mv divided by delta t, or F into delta t is equal to mv minus, or we can write m plus is also represented by j is equal to F into delta t, or we can write mv minus mu as in a change in momentum. This m plus of force is equal to change in momentum. This is also known as m plus momentum theorem. If sometimes it is asked in the example m plus momentum theorem, m plus you have to prove that this m plus is equal to change in momentum. This is also known as m plus momentum theorem. This is also known as m pulse momentum theorem. Therefore, m plus is equal to j is equal to f into delta t, or you can write it mv minus mu. If I write SI unit, since force is a vector quantity, therefore m plus is also a vector quantity. Is a vector quantity, why it is a vector quantity? Because force is a vector quantity. This time is a scalar. When vector are multiplied by c, it becomes a vector. Therefore m plus is also a vector quantity. Its SI unit is, if I write SI unit, force is measured in Newton, time is measured in second, its SI unit is Newton second. I hope you have, if you have to calculate this sometimes dimensional formula, मैंने आपको already पता dimensional फार्मूला अगर आपको कैलकुलेट करनी पड़ेगी, ये आपने ऑलरेडी सीखा है. फोर्स इंटू टाइम, फोर्स किसके बराबर है? मास इंटू एक्सेलरेशन. आपको वही लिखना, मास इंटू एक्सेलरेशन. ये डिटेल में आपको पता, मास इंटू टाइम टी हो गया, मास एम, एक्सेलरेशन हो गया वेलोसिटी डिवाइड बाय टाइम हो गया, इंटू टाइम, टाइम एंड टाइम कैंसल, मास वेलोसिटी हो गया डिस्टेंस डिवाइड बाय डिस्टेंस बाय टाइम. इफ आई राइट डायमेंशन, मास इज m1, डिस्टेंस इज l1, t raised power -1, ये ऊपर आ जाएगा. दिस इज द डायमेंशनल फार्मूला ऑफ m plus. I hope you have got it. That means the force which is acting on a short interval of time which acts on a body for short time is called m pulse. That means for that we are not able to calculate the force directly. It is very important because the force produced for that time is very large, and it produces this force, this force produced during a short interval of time. Practically it is very impossible to calculate that large amount of force and that short interval of time. In that case we are going to calculate the m plus. It is very easy to calculate the m plus because m plus is equal to change in momentum. We know that mass and velocity, final velocity and general velocity, we can calculate the change in momentum, and change in momentum is colloquially known as m plus, that means force into delta t. I hope you have got it. Thank you. We meet in the next class. Thank you very much.